Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Scott.
And in studio with us we have Kenny. And Kenny, if somebody needed to get a hold of us, what would they need to do?
For math homework help, call 636-186, in Bakersfield, 636-4357. Everywhere else, 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net. And on social media, Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. So Kenny, where do you go to school and what grade are you in?
I go to school at Laurelglen Elementary, and I'm in 5th grade.
How's 5th grade going?
It's pretty good.
It's pretty good?
Yeah.
What would be better about it?
If
I
could
mean, it's
go,
not excellent, is it?
No.
All right, so what would make it better?
If I could go back right now.
Yeah, if you could go back, huh? Probably that's what a lot of kids say. So I know that in a couple of weeks, I think some of you may have an opportunity to go back to school.
Yeah.
So are you going to do that, or are you going to stay kind of like with what you've been doing?
I'm going to go back
Oh, you're going to go back?
next week.
All right, cool. I think next Thursday or something like
Yeah.
that, the 18th, you guys get to go back in 5th and 6th grade?
Yeah.
All right. So have you seen a lot of your friends, or is that one of the big things you're looking forward to?
I've only seen one of my friends.
Yeah, it's been pretty tough this last year, huh?
Yeah.
All right. Well, you know what? During the past year, you did. I mean, looking at you, you got a Dodgers shirt on right there, so you must be pretty excited the Dodgers won the series, right?
Yeah.
Yeah, that's pretty cool, huh? You looking forward to baseball this year?
Yeah.
All right, good. You have a favorite player?
I like Cody Bellinger.
Why? Anything in particular?
No, I just like.
He hits a lot of dingers, doesn't he?
Yeah.
Yeah, a lot of home runs, man. He sends that ball flying. All right. Well, you know what? We do have phone tutors available until 5:30 this afternoon, as we do most Tuesdays and Wednesdays throughout the regular school year. We have another guest coming in, and we'll visit with him in just a few moments. But right now, we're going to get you started right off the bat. You ready?
Yeah.
So what have you been working on in school right now?
I've been working on like measuring.
Customary units, right?
Yeah, customary.
Okay. And when I was looking at your paper, a lot of it is cups, quarts, pints, things like that,
Yeah.
right? Are you pretty familiar? You feel pretty comfortable with those?
Yeah.
Have you ever heard the saying, mind your P's and Q's?
Only once.
Only once?
Yeah.
Well, that's pretty good if you only heard that once. When I was a kid, I heard mind your P's and Q's probably every day or something like that. But anyway, Scott might even be a little young for that one, but I'm sure he's heard mind your P's and Q's. Johnny, I'm sure you've heard mind your P's and Q's when you were a youngster many a time. That means it came from mind your pints and quarts. That means P's and Q's, but to a kid, an adult would say mind your P's and Q's, like watch what you're doing and be careful of what you're doing and pay attention to what you're doing and things like that. So are you ready to do some of these problems from your homework?
Yeah.
All right, head to the board, young man. Let's take a look at these together. So between you and Scott, you guys can write these
grab that
down.
black
So
pen?
we're going to convert
There you go.
different things. So the first one they had, we'll just look at it. And we know that they said that 5 gallons is equal to 40 pints.
Mm-hmm.
Now, underneath that, they give a little bit of information. So, Kenny, do you know how many quarts are in a gallon?
4.
4. There you go. So that's useful information. And do you know how many pints are in a quart?
2.
If,
Two?
well,
That's
if
it.
not,
Good
we're
job.
here to help you,
Yeah.
right?
Yeah,
So
you
you've
got
got
it.
2 pints in a quart, and you've got 4 quarts in a gallon. All right? So, now what I want you guys to do is just think, okay? You've got 1 gallon.
Okay.
How many pints? This isn't even up, it's not one of the questions up there. But let's just start with this. If you have 1 gallon, I want to know how many pints you have.
Okay.
Because you already said that there are
4
4 quarts in a gallon
Yeah.
and 2 pints in a quart. So use that information, and you've got Scott to help you out if you need to.
So what do you think? How are you going to attack this problem here?
So 1 gallon is equal to 4 quarts?
You want to write that down just to make
Yeah.
sure we have that information? Yeah, you said it out loud, but I think it's always good to write it down just so you don't forget. 1 gallon,
Equal
and that
to
equals 4 quarts. Good.
quarts.
And so if we were shooting for quarts, we'd be all done, right?
Yeah.
We're not quite shooting for quarts, though. We got to go a little bit further. So what other information do you know?
A quart is equal to 2 pints.
Aha, so put that one down too. 1 quart, yeah, is 2 pints. There they are, all the P's and Q's that we need, and a G. All right, how do you want to attack this problem? What do you think? What are we going to do with this?
Okay, so 1 quart is so 2 pints.
Mm-hmm.
We will look for. So 1 gallon is equal to 4 quarts.
Mm-hmm.
So
And I'm going to draw them out here for you.
Yeah.
Sometimes that helps out a little bit, right? There's 4 quarts, right?
and then 2.
Now, in this one right here, in this 1 quart right here, how many pints are in here?
2.
Right, so there's a pint here, oop, and there's a pint here, right?
Yeah.
How about in this one?
There are 2 pints.
Yeah, how about in this one?
3 pints.
Yeah, there's 2 in that one, right? There's 2 in every one of them.
Yeah.
And that's kind of what I'm trying to show you here, is that each one of them, if you split it up, you would have 2 pints. So if we had to add all these together, I didn't draw them all out for you, but you can kind of see a picture of what's going on.
Yeah.
How many pints would you have in total?
8.
8. Now you can see the picture of it. Tell me the numbers that you have written down and what you would do with them if you didn't have a picture.
So 4 times 2 is 8.
There you go. Gotcha. That's exactly right. So the answer that we're looking for is 8 pints, and you
Yeah.
get that by multiplying. And I want you to think a little bit about, as we do some more of these problems, as you go from something big, like a gallon, to something smaller, you're actually going to multiply.
Yeah.
Okay? So that's something to think about as we do some more of these problems. Sometimes you go from small to big, and you would divide. But in this case, we went from something big to something small. We're going to do a multiplication problem, and you had 2 numbers that you wrote up there. 4 times 2 is 8. So that's a good start.
Good. Now, Kenny, if you could do me a favor, everything in red, if you could circle that with your eraser and get rid of it, everything in red.
Nothing personal, though, right?
No, just making more room. But the stuff that he's written down in black is going to be useful.
Very good.
Right?
Good point. That's right.
So, Kenny, I'm going to give you an option. You can choose a number between 2 and 9. What number would you like?
4.
4? All right, let's take a look at problem number 4. It says 240 fluid ounces, so we have 240 fluid ounces is equal to how many cups?
So
Okay, what do you think, man? In the information that you've written in black, did you write anything about ounces?
no.
No, doggone it. Okay, well, how about this? Did you write anything about cups?
No.
What the heck? Apparently this information that you've written down is going to be useful for another problem, but we need some more information. So let's see if we can figure this out. Do you know how many fluid ounces are in 1 cup?
8.
That's right. That's it. So why don't you go ahead and write next to that or underneath the other information that you have there, either way. Somewhere that you have it, you're going to write that down. 8 ounces is 1 cup. I'm glad you have that information in your head. That's good. And as you write that down, just real quick, do you know why we have to write fluid ounces?
No.
There are some other ounces when we're measuring, and that's about weight, about how much something weighs. So we'll talk about that later on. I don't want you to get too confused, but you're right. I'm glad you put down fluid ounces. 8 fluid ounces in 1 cup. So tell me this. We talked about that last problem, and we went from something big to something smaller. Remember that? We multiplied. So tell me about this process here. If you go from ounces to cups, are you going from something big to something small, or from something small to something big?
Something small to something big.
That's it. You're going from small to big. So tell me what kind of operation we're going to use.
Divide?
That's right. Good job. You're doing a really good job so far. That's exactly right, because the last one was multiply. Now we're going to divide. Tell me which numbers we're going to divide.
240 fluid ounces divided by 8 fluid ounces.
Knock it out. Go get them. So we're dividing 240 divided by 8. Okay, talk me through this. What are you going to do here?
So 2 can't go into 8, so 20. Wait, no. 8 can't go into 2, but
Right.
8 can go into 24 3 times.
Yep.
Three
Once you
times
go, make
eight.
sure that 3 is right over top of the 4, too, because remember you said it couldn't go into 2,
Oh, yeah.
but it can go into 24. There you go.
So 3 times 8 is 24.
Mhm.
24 minus 24 is 0.
Yep.
Bring the 0 down.
Good. I'm glad you did that.
Divide. 0 divided
Yeah.
by 8 is 0.
Yeah,
So
and that's a
times
really
eight,
important 0,
0.
huh?
0 minus 0.
And there's nothing left
0.
there.
Yeah.
That's it. So 240 fluid ounces equals how many cups?
30 cups.
All right, why don't you go and put that in the blank spot there? And it looks like you're getting awfully good at this.
Now,
Well done.
Kenny, I dare say you could have done that mentally.
Yeah, I think you're probably
So,
right.
Scott, what I want you to do is go over with him how he could have done that mentally in case he's kind of in a hurry sometime
Sure.
or doesn't have something to write on. Because, Kenny, you already have the knowledge
Mm-hmm.
with your times tables to be able to do that. So, Scott's going to go
Right.
over with you quickly how to do that mentally, which I'm sure you can do.
Yeah, good point. So here's how you can do this awfully quickly. Do you notice that at the beginning of the problem, 240 had a 0 at the end?
Yeah.
And also at the end of the problem, 30 had a 0 on the end. Do you see that?
Yeah.
Okay, so here's what you can do. You can just take what we call in math the significant digits, the digits that are not 0. So in this case, it'd be just 24, right? And you told me that you're going to divide. That was a wonderful observation. So what is 24 divided by 8?
3.
That's right, and that's what you wrote right there. You can't forget about this 0, but what you can do is just deal with the significant digits, get an answer here, and then take that 0 and add it on the end.
Yeah.
So do this problem for me here real quick. How about this? We'll even keep the 8. So tell me what 720 divided by 8 is. And you're not going to actually do the math. Here are your significant digits. See if you can actually just put that answer right at the top of that problem I've written down without actually working out the division. Tell me what happened there. How'd you know it's 90?
72 divided by 8 is 9.
That's right.
I took the 0 and added it to the end of it.
There you go, real quick, huh? So you wouldn't even have to write that down. You could take a look at something like this problem and say, you know what? 24 divided by 8 is 3. Write down the 3, add the 0. Not a whole lot of work to do. We always like to have work shown, especially as a math teacher. I'd love to see my students work to see what they've done. But sometimes if you're in a real big hurry and you want to get it done real quick, you can do a little mental math.
Right,
And
which
that
is
was a
why
good
I
start.
wanted you to do that, to see that you can do it.
Yeah.
And sometimes all it takes is a little bit of practice, and you'll get, really good at it, and you can be able to get through more difficult problems
Absolutely.
easier.
Yep.
All right, Kenny, so you chose number 4. You have another number to choose between 2 and 9, but not 4.
5.
5, all right. 32 quarts.
Okay. Oh, 32 quarts.
Okay, is equal to how many gallons?
Ooh. Okay, I'm going to let you take over on this one. What do you want to do with this problem?
Okay, so we're going to smaller to bigger.
Good for you.
So
And what does that
from
mean?
smaller to bigger, we will multiply.
Multiply or divide, one or the other, huh?
Yeah.
Remember? Let's look back at the top here. I'll see if I can get this page back for you. All right, what did we do here? We went from small to big, right? Small to big, and what did we do?
We divided.
Divided. All right, so let's go back to this problem here. Are you going from small to big or big to small?
Big. Small to big.
Small to big. So what are you going to do?
Divide.
Divide, that's right. And which numbers are you going to divide?
32
Uh-huh.
divided by 8.
How many? 8? Tell me where 8 came from.
4 times 2.
Ah, gotcha. But look at specifically what it says here. It says 32 quarts, right?
Yeah.
It does say 32 quarts.
4.
Yeah, it says just 4, actually. You're exactly
Yeah.
right. So actually a little less work than you were thinking. But I know where you were going with this. So go ahead and work that out. 32 divided by 4. That's it. Nice job. And you know you're dividing. Is there a way that you could check this answer? If you weren't 100% sure, if you weren't exactly like, I know that's the answer. Well, I'm kind of, maybe I'm not quite sure. How could you check this answer to make sure it's right? You could divide it that way. What about if you had the answer of 8, right? Just this answer 8. How would you get back to 32? Yeah, you go back and multiply times the other conversion factor, right?
Yeah.
So there's a couple of different ways to do that, but that's it. That was a pretty quick one.
All right, there you go. Well, you know what? I gave you options on the first 2 problems that you've done. Now we're going to go to the bottom of your paper and go to number 17.
Uh-oh.
All right?
Okay.
So take a look at the problem here, Kenny. A recipe calls for 32 fluid ounces of heavy cream. How many 1-pint containers of heavy cream are needed to make the recipe?
Whoa.
So you need 32 ounces of heavy cream.
Okay.
How many 1-pint containers are needed?
Getting hard to write here. Okay. Kenny, where do you want to start with this one, buddy? How many
So-
1-pint containers?
Oh, it's just regular ounces, huh?
What's that?
Are these just regular ounces?
Yeah.
Okay.
Yeah.
Worked on that, yeah.
So what's the information that you already have that we've used before about ounces and pints? Do we have any information about that?
A pint is equal to. Pint is equal to.
We need to kind of get the pints into ounces, huh?
Yeah.
Yeah, that's a good idea. So what about ounces and cups? You had that part, right?
Yeah.
Can you
8.
write that again? What was that again? 8 ounces in 1 cup. How about how many pints, or sorry, excuse me, how many cups in 1 pint? Do you know that one?
2?
That's right. That's it. So we have a couple conversion factors. 1 cup equals 8 ounces. You told me that, right? And 1 pint equals 2 cups. So if you were going from ounces to pints, right? A little bit messy there, but you can kind of see what I'm doing, hopefully. How many ounces are in 1 pint?
So ounces. 8 ounces. 16?
That's it. Good for you. You're definitely doing some mental math here. Okay, so we squeeze it in there. 1 pint equals 16 ounces. And I'm going to let you follow through on the rest of this problem. So if you know that this 1 pint right here that we have, this 1 pint is actually 16 ounces, how many of those containers do you need to make 32 ounces?
1 pint. 2.
That's it. Tell me how you know it's 2.
16. So 1 pint containers, 1 pint is equal to 16 ounces. 16 times 2
Uh-huh.
is 32.
That's it. So that's a good way to do it there. We had to do a little bit of work beforehand, right? A little
Yeah.
bit of work beforehand. What's another way you could do this? What if we just started with 32, right? We wanted to get into pints.
32.
So for instance, we'll take this first one that we have here, right?
Yeah.
32 ounces is how many cups? How many cups would be 32 ounces?
4.
4 cups. How'd you get that?
32 divided by 8.
That's it. Good job. All right, so you have a little bit of math going on there. What about this one? Now, how about if we wanted to take cups, 4 cups, into pints? How would we do that?
8.
Think about that a little bit longer.
Okay, so 4 cups.
Cups into pints. We're going from something small to something bigger.
2?
That's it. And that's where this number comes from that you already did right here, right?
Yeah.
So 4 cups is 2 pints. There's a couple different ways to do this. I like the way you did at the beginning, but no, there's always another way to think about it a little bit. And
Yeah.
those numbers are rumbling around in your head, but I think you're keeping them pretty straight. It's pretty
There
impressive
you go.
so far.
Nicely done. I know you guys were talking about fluid ounces and things like that a lot. But Kenny, for your great effort so far, we're going to give you some solids, some solid food. You've got yourself a meal courtesy of our friends at Grill and Burger, so congratulations on that. Hopefully you have an opportunity soon to go see Liddy and tell her you were part of the show, and she'll be more than excited to see you. We'll be back with more right after this. All right, well, Dave, there's a lot of amazing things going on at the purification plant, and this is one of the spots because as people drive by, they can see a lot of the things that are going on, have a lot of questions about it, but we're subterranean now, and this is a spot where a lot of people are not able to visit, so thank you for bringing us down into the basement.
No problem.
But anyway, I know that we've got some backwash pipes going on and some other
Yeah.
things. What is going on down here?
We're actually in one of our treatment trains, what we refer to as the pipe gallery. So we're actually below the filters and sedimentation basins. And what this is really one of the last stops of the water while it's in our purification plant. So by the time the water comes down out of the filters, it's been filtered. From these pipes, it's delivered in for storage into one of our clear wells. We have 12 filters here. Over time, those filters may need to be refreshed. And so we are actually able to backwash those filters. We have the different color of pipe here. The pipe with the blue contain the water that has been filtered, will be delivered for drinking water. And then when the filters need to be backwashed, that water will be delivered through these lighter green pipes here.
So I see you're analyzing something over here. What exactly is going on in this system?
These are turbidimeters, and these analyze the clarity of the water. And these readouts here are the same readouts that an operator will see when they're in the control room operating the SCADA system. We are required to have an operator present 24 hours a day, 7 days a week, 365 days a year. In other words, we never close.
No Christmas off,
Yeah.
no Thanksgiving, no New Year's.
Someone does get to work during the holidays. So the operator we have today, his name is Derek Guffey, and he is here in charge of the plant.
Now, Derek, I'm curious, what actually got you into your career in the water industry?
Believe it or not, I actually found an advertisement in the newspaper for a water job, which actually started me off across the street at the Cross Valley Canal. And 5 years there, after that I moved over to here, and I've been here for 4 years.
And what do you find most interesting about this whole filtration process?
The job itself is very interesting, but apart from the job on the outside, the thing I find most interesting is really serving our community, because operators that operate plants like this, they have to have the dedication, the knowledge, and the diligence to provide the best quality product that we can. That kind of responsibility I find interesting and very rewarding.
Well, you do have a big responsibility because you're in the control room.
Correct. Everything is remotely controlled. We can do everything from this station you see right here. What you're seeing on the screen is almost accurate almost all the time. But whenever we see something, we always back it up by a bench test over there at our testing station, or physically go out to the device that might be showing an alarm and see if it's actually happening.
Well, Derek, I know you have a lot of responsibility up here, and Olivia, we're going to put some of that on you right now if you're ready.
All right.
You want to take Derek over here and we'll do a little bench test?
Sure.
All right.
Absolutely. Well, this is our bench testing area where we do all different kinds of testing on the water that comes into the plant and leaves the plant. So right here we have a TOC machine, which is a total organic carbon. Here we test things like hardness, chlorides that could be in the water. This would be our pH testing unit. And our bleach or chlorine testing. And the last one, which we're going to show you guys, is turbidity. Tested in NTUs, which are nephelometric turbidity units. That's a big word, but basically all it is the clarity of the water. So how clear is the water? Is it really cloudy or is it really easy to see through? And basically what the machine does is it shines a light through the sample and gives you a numerical readout of exactly how clear the water is. So we'll do a test on our raw water, which is our incoming water, and then we'll do a test on our outgoing water. So anyway, so we'll take our little vial out here and we'll dump the old sample out. We'll take a sample of our raw water. We got to make sure it's clean so we don't have any errant results. And then we'll just pop it in there. We wait for the readout, so it's shining the light through it right now, and basically we have a number of 0.73. Okay, so if you remember that number, it's 2/10 under a whole 1. All right? We'll take it out now and we'll dump that out. We'll give it 3 rinses. Let it clean again. So what you're seeing is the beginning and the end. And in the middle here, what you have is samples from the entire process until the end. So sedimentation, filtration, through our clear wells, which basically store the water before we send it out through our distribution system. And then this is the end at the distribution system. And as it goes through the system, the water should get more and more clean until it ends up at the final. So as you can see, it's going down. So we started at 0.73, 0.74, 0.75, and now we're down to, should stabilize at about a 0.08 right now. So that's just one of the tests we do to make sure that the water that we're sending out to the customers is clean, safe, pure.
All right, so what does this machine do?
So this instrument is an instrument we use to measure metals, and as I said, it has about 4 different methods of doing so.
Well, just a reminder, we do have phone tutors available until 5:30 this afternoon, but time now for a visit from our friends at Science for Kern. All right, we love having Science for Kern in studio. Michelle, how are you today?
I am doing fabulous, Mike.
Good,
Glad
nice to
be
see
here.
you. And what will you be doing today?
Well, today we are going to be doing some investigations around electricity and magnetism. And I have actually 4 different activities that students could try at home today. Kenny, are you ready to do some science?
Yeah.
All right, so how much experience have you had with playing with magnets?
I haven't been playing with magnets so much.
Magnets can be sort of magical, I think anyway, which is the perfect segue into our first activity. So I have some brick magnets. I'm going to let you grab those, and let's start. Can you take them apart?
Yeah.
All right. Ooh, what happens? What happens?
They pull together.
They pull together.
They attract.
Oh, there you go. It's attract, right? And how does it feel?
It feels like it's really it's really attracting.
Yeah, these are like Hulk magnets, right? They really are strongly attracted to one another.
Yeah.
So see if those 2 magnets you have in your hand, if you can get them to repel one another. Ooh, look at that. How does that feel?
It feels weird. It's like it's repelling.
Oh, check that out.
There's a force.
All right, so you want to have some fun on the table now with our magnets? All right, so let's put them down. And let's try red side up first. And if we pretend like they're cars, right? We're going to be like little kiddos playing in the dirt, right? And let's try to drag our cars next to each other this way. Have them come together. And then what happens when they get close together?
They start to repel a little bit.
Yeah, can you get them to go together?
Yeah.
But you got to push really hard, right? Oh, look
Yeah.
at them. And look at that. Yeah, they want to push against each other. So we call it, what's that called when they push against each other?
Positive and negative force.
Oh, no. Even bringing in that new idea too. We'll add that later. So can you get those 2 to attract then? What do you need to do for them to attract? All right. So can you now, with these 2 magnets, could you get one magnet to actually push the other magnet across the table? Check that out. So do you notice anything, what do you notice about the colors right now when they are repelling? What do you notice about the colors that are facing up?
They're both red.
They're both red. All right, so when they repel, what's the color combination that's up top?
Red, red.
We got red, red when they repel, all right? So what color combination do you have when they attract?
Blue, red.
Okay, so are we ready to make a statement, something like when the colors are different,
When the colors are different, they attract.
okay, and when the colors are do you think it's the same for blue and blue? Try it.
Yeah. No. Oh, wait.
So blue and blue repels or attracts?
Repel.
Okay, so consider that, and let's move these aside for a second, and let's take a different piece of equipment here. Could you, based on what you know about blue and red and attract and repel that we explored here, could you put all those on there where one magnet actually floats on top of the other magnet and floats on top of the other magnet, where they all are floating? Let's see what you can do with that. Ah, look at you. So tell me, how did your exploration with these magnets help you just know how to do that? Because man, that was fast.
When the colors are the same, they repel. When the colors are different, they attract.
All right, so does the same thing happen with those magnets that happens with these, with the red and blue thing?
Yeah.
With attract and repel?
Yeah.
Yeah, so when they're floating, then we say they're doing what to one another?
They're repelling.
They are repelling. All right, awesome. So let's put those back on here and move this aside for a second. And let's do an activity related to that. You take a straw, and I'll take a straw. And this is really fancy equipment, isn't it? Only the best scientific equipment for my friend Kenny. Take a napkin. Are you ready? So we are going to electrically charge our straw. Are you ready? So take your straw, and we're going to hold just a little pinch at the bottom, just kind of hold it there, and then take your napkin, wrap it around the straw, and let's rub for about 30 seconds. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Look at that! Does yours do it too? Oh, look at that! Oh. So, what is going on there?
The electric charge made the straw stick to your hand.
It did, didn't it? Well, do you think that whatever, and eventually it loses its electric charge. So do you think that what's going on with the straw and the napkin here has anything to do with our magnet activity and the ideas of attract and repel?
Yeah.
Okay. Just explain a little bit about what you're thinking so far.
When something is electrically charged, it could attract, and when something isn't, it repels.
Okay. Awesome. You've got an incredible beginnings of a theory there. So, when we electrically charged our straw, it did what to my hand?
It attracted to your hand.
It attracted to my hand. So if we were thinking about the colors on our magnet, then my hand and the straw would be like what colors?
Red and blue.
Yeah, it would be like red, red, or blue, blue, right? So when there's something about our electrically charging that causes that attract, right? So they're the same You started getting into positive and negative a minute ago. You wanted to say something about that? Do you know something that might have, do you have any thoughts about how that might be related
Maybe.
to our magic move there, or straw in our hand?
Maybe when something is electrically charged, positive and negative, I forgot what they're called, but positive and negative,
Electrons.
yeah, electrons,
There you go.
they attract.
Okay, so positive and negative are different.
Yeah.
Right? So they, if they're different, the opposites attract, right?
Yeah,
All right, you want to try one more activity
yeah.
before we finish up here today? All right, so we have a balloon, again, like, because we want our friends at home to be able to do science along with us too. So simple stuff you have at home. And I hope tonight you go home and show your family all these fun things we did together. So I got a balloon and an empty soda can, right? Just a regular old empty soda can. And we're going to electrically charge the balloon. I'd have you blow it up too, but we can't take our masks off, so I'll just demonstrate. And we're gonna, whoops, I gotta get a good grip. I'm going to electrically charge the balloon, right? Get it good and charged up. And what do you think's gonna happen when I put the balloon near the can?
It'll repel.
Repel, you think? Let's see what happens.
Oh, it'll attract.
Oh, look at that. Yeah, whoop, stop there, can. Look at that. So, is my hair sticking up all over my head?
A little bit.
Okay, we'll fix it. So what was going on there that was like the straws, like the magnets?
Positive and the negative. The positive and negative electrons, they attracted.
Yeah, so when I was rubbing this on my head, we were doing, what's that called? We were electrically charging it up,
Yeah,
right?
good charging.
So if it was, because, and right now our balloon lost our charge, so if I started rubbing on my head like crazy, again, we'd recharge the balloon and we'd get the can to move again. So that positive and negative thing, the can and the balloon did what?
They attracted.
Okay, so what charges then would you assign, positive and negative, to the can and the balloon?
Positive, negative.
You are an amazing scientist, Kenny, and I so enjoyed working with you today.
Thank
so
you.
well done.
All right, thank you,
Thanks,
Michelle.
Mike.
And once again, Science for Kern. If somebody wanted more information, Michelle, where would they need to go?
They would go to scienceforkern.org and click on the resources button and check out all the great 10 different Science for Kern units that are available to teachers to check out, even between now and the end of the school year.
All right, thank you very much for that once again. And we'll be back with more right after this.
Hi, I'm Nidaria. And I'm Kat. We're going to talk about how lights and shadows affect living things in nature. When we go outside, we see all sorts of different ecosystems. A few that we have in this area are chaparral, like this. And forests that look like this. In general, we know that plants need sun, water, soil. How much of each of these can change depending on what type of plant it is or where it lives. Here in the chaparral, there's a lot of sun. Every plant we see gets plenty of sunlight as long as it's daytime. Their leaves are small and they're designed to not dry out in the hot sun. This coyote brush has a waxy coating on its leaves. That helps to keep its leaves moist even when there's months without rain.
While the chaparral gets plenty of sun, the soil here is more sandy than nutritious, and the area doesn't get much rain, so most of the plants here stay pretty short.
Animals that live in the chaparral either really like the sun, like this western fence lizard, or can hide quickly in the plants, like this brush rabbit.
Here in the forest, it's a little different. These tall trees are blocking out a lot of sun on the forest floor. So the plants here have to adapt. a lot of them have wider leaves to help them to better get the sunlight that can peek between the tree's shadows that change throughout the day. These butterflies enjoy perching high in the trees so they can feel the sun first thing in the morning. Birds make their nests up high to avoid predators, but in the shade to protect the chicks from the sun. While the trees block a lot of the sun, they also help to keep the soil from drying out too quickly. So the plants here in the forest are a lot less thirsty than those that are in the dry chaparral. What I think is so interesting about leaves is that they have these little pores, tiny holes that help them to bring in carbon dioxide and release oxygen. Thank you. Those little pores can also release water.
Hey Kat, I've noticed that sometimes when I'm in the sun a lot, I sweat. I don't have a waxy coating though. I wonder if plants without a waxy coating lose a lot of water from their leaves. What do you think?
That's an interesting question. I wonder how we could answer that question.
You know, I think we could do an experiment to find out and see if leaves that are in the sun lose more water than leaves that are in the shade. What do you think?
That sounds awesome.
I think we're gonna try it. So, I wanted to test this idea of whether sun and shade has an effect on the plants and how much water they might release into the atmosphere. So, I'm going to show you my little bag of tricks. What I have in here and what we need for this experiment is actually very simple. So we need a tree or a plant. So here we are underneath this beautiful coast live oak tree, and I chose this tree because it's a big sprawling tree, so the branches go out really far. So there's a lot of leaves that are in the sun and that are also low enough to the ground that we can have access to them, and a lot of leaves that are in the shade because they're covered by the canopy. So for this experiment, all we really need are 2 plastic bags. I've labeled one of them shade and one of them sun, and some tape. All right, so I'm gonna take you with me when I set up the experiment. So here we go. Leave that set up for a few hours, and Kat is actually going to come out and I'm going to show her, it's a surprise to show her what happens with my experiment. So I want you to make a hypothesis while we're waiting. Do you think the leaves that are in the sun are going to release a different amount of water than the leaves in the shade?
Daria, how's the experiment coming?
Hey Kat, well, I've had it running for about 3 hours and I think I'm already starting to see results. Come check out these shady leaves.
Ooh,
cool. So I noticed that the leaves I had set up in the shade are now getting a little bit more sun, so I think the tree's shadow has moved.
I noticed there's a little bit of moisture in the bag. Is that from the plant's transpiration?
Yes, it is. Let's compare this bag to the leaves that were in the sun.
Whoa, there is way more moisture in the bag for this one. I wonder why that is.
Well, this bag has been in the sun for the whole time during the experiment, so the leaves have lost a lot more moisture. So that's what we've captured in the bag.
That's so cool.
Yeah.
Well, that was fun. Thanks, Nidaria. I really appreciate you teaching about how lights and shadows can affect plants.
I'm so happy to. And students, you can do the same experiment at home and maybe add on your own ideas, so you can extend the experiment, maybe experiment with a few different plants, whatever you want to do.
Thanks for joining us.
Bye.
Always a lot to learn at Camp Keep, and Kenny, that's something that you might be able to look forward to next year's Camp Keep in 6th grade. That's when students are able to go. We do have phone tutors available until 5:30 most Tuesdays and Wednesdays throughout the regular school year. In studio right now, we're fortunate enough to have Gustavo with us. Gustavo, you are associated with the
Black Chamber
of Commerce, Kern County.
Correct.
Or
I'm a
now, is it
volunteer.
Kern County or Bakersfield?
It's the Kern County Black Chamber of Commerce.
All right, so it's the entire county.
Correct.
And what is your role with the chamber?
So right now I'm only a volunteer with the Black Chamber.
But don't say only a volunteer, because I'm telling you right now, all these places love having volunteers, and they would not survive if it was not for volunteers.
I love volunteering and anything I can do to help my community.
Now, we already had Nick Hill, the president and CEO of the Chamber, come on, and he talked to us quite a bit about the Chamber and what they're doing.
Correct.
So I want to get into exactly your part and how you got associated with Nick, because you've got a pretty interesting program dealing with computers and kids. So can you tell us a little bit about that?
Sure. I came on to volunteer with the Black Chamber after I built them their website. I was talking to Mr. Hill about how I would love to create a program that I had in the back of my mind called Operation Reboot, where I would collect used computers from businesses that were going to be throwing them away or just discarding them, and salvaging those computers, repairing or giving the computer that they were tossing a fixer-upper, whatever it needed, and tearing it down, just completely putting everything in a box, and having a couple of kids, after I've collected a few of them, having a couple of kids show up, and we would donate our time to show them how to build these computers. At the end of the day, when they built their computers, they would take those computers completely free, just so they can have a computer at home and work and use and utilize, instead of just ending up in the junkyard somewhere.
Right, and they don't have to worry about, hey, Mom, Dad, can I use your computer?
Absolutely.
I'm using it. Well, can I get my own computer? Well, it costs money to get another computer.
Yes, it does.
Well, here you go. This doesn't cost them anything.
It does not.
Right? Do you find that there are some businesses, and I'm not sure exactly, like how long have you been doing this?
So I started doing this about 3 years ago. It's a little bit harder for me to just walk into a business and say, I have this, I'm not a nonprofit, I don't have a nonprofit number. So it's a little skepticism behind the businesses who do give their computers. But I have had the opportunity to get some donated, like CSF has donated some of their computers that they were tossing out. So every year they give me whatever they have. But it is a little bit harder when I'm not a nonprofit. So now that I have the Kern County Black Chamber of Commerce helping me, I feel like this year we can, and we're going to have it in June, this year we can have, you know, a great outcome.
There you go. And you know what? I mean, I was going to say, do you notice some businesses or certain sectors that get rid of these things more often than others?
Yeah, they do. I've found businesses that get rid of, you know, every year 10, 15 computers, and I just can't, I can't fathom the idea of nothing really.
Yeah.
They just throw them away and they end up in the junk, and realistically, really great, really nice functioning computers that somebody could use.
And there've got to be places like this in every community.
Every community.
You know, where they're always looking for, all right, you know what, it's still useful.
Yes.
Let us take it and use it somehow. Or if there's one thing wrong with it, you were talking about how you right now will take out of your pocket money if something
Correct.
needs one thing and you can't find it on another computer to put it together, that you'll do that for the students.
Correct. And more, in several occasions, I'll grab 2 computers and I'll build one out of it. If I find that it's just missing maybe an SSD drive, so then, you know, I'll just order a solid state drive, and then, you know, we can have 2 computers. But it is a little bit difficult because I do pull a lot of money out of my pocket so that I can have these computers ready for the kids. I do encourage people that even if you don't have to be a business, if you have a computer at home that you're just going to toss, you feel like you can just donate it, please, by all means, it can go to somebody who can really use it.
Right, so it doesn't have to be a business getting rid of 10 or 20 of them.
Correct.
It could be an individual and they say, hey, you know what, I've had this, it still works pretty well, but I'd like to donate it to you
Sure,
guys.
yeah.
Where would people need to go to find out some more information about this?
I encourage you to go to the kcbcc.co, that's the Kern County Black Chamber of Commerce, to get more information. You can also go to webbuildme.com, and we'll have further information as it progresses. Again, we do want to have this camp in the summer around June or early July. So the more computers we get, the more we can help out any kids.
And I remember you talking about there were some students that you were saying, listen, a child as young as 6.
Yeah,
you would take them.
6
and
years
help them.
old, absolutely. I know it sounds crazy, like, oh my God, 6-year-old, how are they going to work on computers? I'll tell you what, more and more kids around 5 or 6 are grabbing tablets, are grabbing phones. It's something that's just becoming more and more just usual. People are just doing it now at a younger age. So the more you get them ready for what the future is, the better they'll be off. You know, they'll have a better chance at life.
And if you get a 6, 7-year-old kid and they're building their own,
sure,
they've got a little career path going
absolutely,
on right now.
Yeah.
Also.
I remember back when I was in high school, it was hard to get computers. Now computers are all over the place. We just got to give it to the right people.
All right. So once again, if somebody, they're like, yeah, you know, this sounds outstanding, where do they need to go again?
Go to the Kern County Black Chamber of Commerce at the kcbcc.co, or you can also go to webbuildme.com.
All right, perfect. Well, Gustavo, I certainly do appreciate you taking some time coming down and discussing this with us. And I know there are a lot of students that are going to be viewing this program going, oh, I can build my own computer. I want to do something like that, and I can get my own computer. And businesses and individuals may be watching this also going, oh, now we know what to do with our other computers.
Absolutely.
We can give them to Gustavo in this program. Operation Reboot?
Operation Reboot. And we encourage parents to please, please, please attend this program with your child. It is a really nice bonding experience, and you also get to learn something that you may have not known.
Right, there you go. All right. Well, we do have phone tutors available until 5:30. Thank you once again, Gustavo, for coming in. Kenny, are you ready to get back to work?
Yeah.
All right, over to the board, young man. You did well with your units of capacity and all of the liquid measurements. Now we're going to do something that you're going to start on at the end of this year, and you will be doing in 6th grade also. All right? So let's try this. 8 minus, so you can go ahead and write this up on the board, Kenny, if you want. 8 minus, oh.
Go ahead.
6. And solve that problem for me.
That's pretty quick. Jeez. Man.
All right. Now here's what I'd like you to do. I would like you to write underneath that 8 minus -6.
Uh-oh.
There we go. So if you're stuck, Scott's there to help you out.
8 minus negatives.
What in the world did you do with that? Thinking. He's definitely thinking. Tell me about your thought process there about how you came up with -2.
So 8 minus -6, I thought to myself, okay, I thought of this problem up here. 8 minus 6 is 2. So 8 minus -6, I thought would be -2.
Okay, gotcha. So you kind of flipping the sign around there. Have you ever seen a number line, Kenny? This is a very squiggly number line, but
Yeah.
you've seen that before? Okay, so let's say we have like 0 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and if you were to do the first problem on a number line, can you show me by kind of bouncing up and down on the top or on the bottom of this number line what you would do? Where's 8 on the number line that I've drawn? That's it right there. Now, if you were going to subtract 6, what would you do on the number line? 1, 2, 3, 4, 5, 6. What's the number you entered at? 2. That's it. You got it. So let's do this. Let me draw you another number line real quick. Okay. Again, I'm pretty good at squiggly number lines. We got 0. We got 1, 2, 3, 4, 5. We got 6, 7, 8, 9, 10. And we got 11, 12, 13, 14, 15. Okay. I just kind of numbered every 5 to make it a little bit quicker. So if you did 8 minus 6. In other words, you started at 8 and you went in the negative direction, right? You went down 6. So where's the 8 on my new number line? Put a dot there so we know where that is. There you go. So that's where you would start, right? And in the first problem, it said 8 minus 6, and you went this direction, right? But this one says 8 minus -6. It changed the sign. So which direction do you think you might have to go for that problem?
This way?
That's right. How many spaces?
6.
6. So why don't you go ahead and do that? Show us on the number line. 1, 2, 3, 4, 5, 6. What number did you end up at?
14.
14. Interesting. So I like what you were thinking here, but we're going to make this answer a 14 instead.
Oh, okay.
Because you kind of have a picture of what's going on here. Now let's make the picture into some math, okay? What could you do with this here minus minus to make this problem make a little more sense? Yeah, it ends up being a plus, huh?
Yeah.
So sometimes you can think of this as a minus minus is actually a plus sign. 8 plus 6 is 14.
Yeah.
Real quick, let's see if you caught on. Ready? What's 3 minus -4? Super fast. That's
All
it.
right,
You got to
good.
change
He's
it
got
into plus. Good job.
All right, wise guy. Erase the board. Let's see how you do with this next one. Here, I'll erase it for you. I got no time. Here we go. All right, 2
Go ahead, can you write that down, buddy?
Okay.
plus -5.
Is
What are you going to do with that? Whoa, got all kinds of stuff going on here. You want to draw me a picture?
no, wait.
Oh, he's got something else. Go ahead. You want to change it? That's all right. Hooray for erasers. Now, where did that come from? Tell me about what's going on in your head.
5 minus 2 is 3.
Oh, 5 minus 2 is 3. And how did you know the answer is negative, though?
Because the negative.
Okay, there is a negative there. That's true. Show me on a number line here real quick. Oops. So we have 0, 1, 2, 3, 4, 5. 1, 2, 3, 4. What goes right here?
Negative 5.
Negative 5. Gotcha. Show me this problem on a number line. Where's 2? Yeah, and what are you going to do? Which direction are you going to go? Yeah.
We're going to go
1, 2, 3, 4, 5. And what number did you end up at?
4? Oh, wait.
No, you're right.
Oh, okay.
What number is that you ended up at?
Negative 4.
Negative. No, what'd you have here? What is
Oh,
it?
a negative 3.
Yeah, you had that answer right. So, what about this? You have a plus and a minus together. What's one way you could combine those two so you wouldn't have so many doggone signs in there and get confused? What would you put there instead?
Minus?
That's it. Yeah, so if you have different signs, a plus and a minus, right, that becomes a minus sign. If you have a minus and a minus, you remember what that is?
Plus.
That's a plus, that's it. So those are good things to remember. If you have too many signs, sometimes you can combine them to make them into one.
Yeah.
Makes it a
And
little
I've
more.
got one more for you.
Oh, one more.
And you get 1 minute to do it. All right?
Got to be quick.
So erase, well, you know what? All right, we've got room up there.
Okay, here we go.
All right, -7
Negative 7, go write it down.
minus -2.
Ooh.
2.
Let's do a little bit of our examples up here. What can you do with this minus minus? Good job. So can you rewrite the problem for us real quick? Rewrite it. -7 plus 2. Good. So we have fewer signs to worry about now. What are you going to do with this? Tell me about your thought process. What's going on?
So negative 7 plus 2. So we do. So what I thought is that negative 7 we add to, so that lowers the negative. So which is negative 5.
Negative 5. That's it. Good job. You did a really good job there. You still have a negative because you're still under 0,
Yeah.
but you went in the positive direction 2 spaces, and I can see that number line working in your head. Good work.
Let's try this. You ended up at -5. So underneath all of that, Kenny, write -5 minus 0. What does that equal?
5
I just wanted to see
0, it
mess you up
definitely
at all.
makes you think, huh? Oh, he's definitely thinking. Now tell me about this. Did
And
you
you've
take
got-
anything away at all?
5 seconds
No.
to do it.
No, it didn't take anything away at all. What's your answer?
negative 5.
That's
There
it.
you
got
go.
it.
Don't let that 0
Ah.
mess you up, even though it looks like more.
Good
All
job.
right. We do have phone tutors until 5:30, and until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.